Okay, so now let's do a brief overview of what systems architecture is, and this is my favorite subject. I'm an MCSE from back in the 2000 era, and I just love to talk about how we are going to be connecting servers and services together. So when we talk about systems architecture, what we are talking about is basically how we are going to be connecting together the resources that are going to be required for your project to be able to do whatever it's going to do, right? When you dive into programming, initially you're going to be thinking about programming languages like Python or SQL, structured query language. It's a database language. We're going to talk about API calls and all of that kind of stuff. And you're going to be thinking, again, how in Python do I make an API call? How in Python do I communicate with a database? How in Python do I read or write files, right? And that's all in the Python world. That's the coding world. But one of the things you also have to think about is how you're going to be connecting to the different resources you're going to need for your project and how you're going to be designing those resources. So a database is what is going to store all of the records for your project. Think about this as if you have an invoicing solution. So every time a customer purchases something, the user enters stuff into some kind of dashboard, and then all of that gets saved as a record in a database. Well, when you say a database, right, that seems pretty simple. And again, from a coding standpoint, that is relatively simple. But one of the things you need to be thinking about is the architecture side. Where does that database reside? Is that database server installed on the exact same server that your web app is installed on, right? So if you use WordPress, right, if you install WordPress, generally WordPress is installed. You use Apache Web Server as the web server that presents the website to the end user. But also you'll have a MySQL database installed on the exact same box, right? So the server, the database server and the web server are on one physical device or maybe one virtual private server. But the thing is, you can actually separate that out, right? You could have the database server be its own server entirely, and then the web server has to connect to the database server, right? So that's a different way you could design for the database resource. Or you could go and you could use Amazon or you could use Azure, and with that, it basically, you get what's called a drop-in replacement for MySQL. And so essentially you can just connect to their cloud infrastructure. And so that way you can read and write to a database solution so that you have access to records. And so that's the kind of thing that we're talking about when we're talking about architecture, right? Is the resource local on the box or on the instance? Is it in another machine? Is it up on the cloud? Basically, when we're talking about architecture, we're talking about how we're going to be designing the communication to the resources that we are going to require for the project that we're creating. Now, when we start thinking about designing our systems architecture for whatever solution that we're creating, we're going to need to consider three main concepts. The first is going to be latency and speed. So normally when we talk about latency, we're talking about network latency, and basically that's how long it takes for a packet to go from your system or from the user system to the server and back again. So normally when we're talking about latency, we're talking about things like real-time communication, where we're doing like a voice over IP call, or we're thinking about things like video games. Honestly, you're probably thinking about video games, right? When you hit the fire button, how long does it take that command to go to the server? So on and so forth. So that's a normal thing you're thinking about latency. But with programming, one of the things you have to consider with latency is not simply how fast the network traffic is, but how long it will take to actually receive the response from the server that you're communicating with. So let's say you're going and you're going to be connecting to an AI service. So OpenAI has something called an API. So you can create Python code that will communicate with OpenAI. You can basically ask it a question and it will give you the response back. One of the things you have to be thinking about is not simply the network speed from your client to OpenAI, but you're going to make that request, it's called a request, you're going to make that request, and then OpenAI has to process that request and then send a response back. right? So one of the things you have to consider is with the system that you're creating, whatever resource you're going to be using, is it fast enough for the solution that you're trying to offer? So let's say you're using OpenAI basically for taxonomy for images. So we talk about taxonomy, that's categories, that's tags, that type of thing, basically text to describe what an image is. So let's say you have, I don't know, 10,000 pictures that have been collected over the years. It's in a data store. It's sitting on your server, and basically you just need to make a request up to OpenAI, say what is in this image, get the response back, and dump it into a database or whatever, right? Probably for that, the latency isn't going to be a big issue. If it takes OpenAI 1 second to return a response, or it takes 10 seconds to return a response, or every once in a while if it takes a whole minute to return a response, who cares, right? You're going to write your Python code. You're going to point it at the folder that has all the images. You're going to point the other side to the API. It's going to do its thing. You're going to walk away and go have a cup of coffee or whatever else until it finishes, right? So therefore, the speed and the latency on that type of project probably really doesn't matter. On the other hand, again, imagine you're using like an LLM type solution, an AI type solution, and you're using it for a chatbot. So you're using it for like a help desk system for the users or the customers of your company. So basically, they're going to come to your little web platform. They're going to ask a question. That question is then going to go to the LLM, the AI. So their question, along with some information that you send along with it, some other stuff, that has to get processed for a response. Well, the issue is like with that kind of thing, 1 second's probably good. If it starts taking like 30 seconds or a minute for that system to process and send a response back, your users are probably going to get irritated, right? And so one of the things to be considering there is what will give you the best speed and performance. Should you use that API call, somebody else's service, or could you install an AI framework onto your own server, basically optimize that server for your users so that they get the response back a lot faster, right? That's what we're talking about when we're talking about speed and latency, and it's going to be something that you're going to need to consider for your projects. The next thing is going to be cost. And not only cost, but cost at scale. And this is what just bankrupts so many startups, right? Because a lot of people go out there and they look at things like let's say using AWS for sending video files, or they look at AI calls with OpenAI, and it looks very inexpensive, right? It's a fifth of a penny. Every time I make a request to OpenAI, it costs me a fifth of a penny. So I'm just going to use OpenAI. Well, that's fine, right? If you and your friends are using the little solution that you've created, it costs a fifth of a penny every time you ask it a question, right? You have to ask a lot of questions before that gets into real money. But here's the thing. What happens when you start getting 10 users per hour, or 100 users per hour, or 1,000 users per hour? All of a sudden, a fifth of a penny times 1,000 times how many questions each one of those people is asking, all of a sudden, that can be a ruinous amount of money. I think about this with AWS and their data storage services. So I knew a company a while ago, and they built their entire infrastructure using AWS, apparently, as I've been informed, and they were going to be a YouTube competitor. And so the thing is being a YouTube competitor, they had to deliver videos. So people were streaming videos. They're streaming high quality videos. Many of them were long form videos. Well, the issue is at that time, AWS charged 9 cents per gig that left their network. So basically let's say a 1080p video file that's an hour long is it's a gig in size, right? 1080p, right? So that means every 1 hour of 1080p video that was getting streamed out literally cost this company 9 cents. They didn't have a revenue model. They were trying to figure that one out, but they were trying to get people to come. So they get all these people to come, and they get all these people to watch videos, and every time people are watching videos, for every hour those people watch, it was 9 cents. You start multiplying that by tens, hundreds, possibly thousands of people, day after day after day, and that becomes a ruinous amount of money. So from an architecture standpoint, you could actually build your own server and put it in something called a co-location facility. Basically, this is where you rent server space in a data center. So it would cost you the money to buy the server, it would cost you the money for the rack, but then past that, you just pay one standard monthly rate. It might be $1,000 a month for a 1 gig connection in a data center. And then you know exactly what you're paying for. So that's something you need to be thinking about with cost. And again, not just cost when you're playing around and doing testing, but cost at scale. The final thing to be thinking about when you're thinking about systems architecture is what is the knowledge base of the people at your company. It's called your institutional knowledge, your institutional capability. One of the big problems, especially for new people in the technology world, is they want to deploy what they know, right? You're young, you're excited, you want to use the latest and greatest, and so you deploy the latest and greatest, which is fine. Problem is, nobody else in your department knows how to work on that thing. Right? You go out there and you deploy some new flavor of Linux, you deploy some new database server that's supposed to be the greatest in the world. One of the big issues that you run into is nobody else knows how to maintain it. Even if they intellectually know what they're supposed to do, I know the task I'm supposed to do to fix this thing. I don't know the commands to actually fire off those tasks. It's going to be a real big issue. And so that's one of the things you have to think about with architecture too, is does your organization have the institutional knowledge to be able to support the systems once you've left the company? That's one of the reasons why a lot of enterprises go with Microsoft. Like Microsoft, hate Microsoft, right? You might hate Microsoft for security reasons. You might hate Microsoft because it's closed source. You may hate Microsoft because it costs a lot of money. But here's the thing. There are a metric crap ton of people that are certified in Microsoft systems, right? If you set up a Microsoft stack for your project and then you leave the company knows that they can hire somebody to fix that stack if there's an issue. It might cost them a lot of money, that type of thing, but they know they can hire somebody, right? If you build your own weird stack, right, that you came up with at the middle of the night one night, the issue is once you leave the company, nobody might know how to deal with that stack. It's not simply that it's expensive for your company to hire somebody that can deal with the stack. They may not know who the hell to hire. Right? So when you're thinking about your architecture, you need to be thinking about basically the speed and latency. You need to be thinking about cost at scale, and you need to be thinking about the institutional knowledge and the ability for your organization to maintain the systems once you've left the company. So the first way you can do systems architecture is simply by just having one box, right? So let's say you have a Linux server and you're going to be using this for WordPress, right? So basically you're creating a blog, that type of thing. So on here, basically you're going to have what's called Apache Web Server. So you're going to install Apache Web Server on to this box. You're then also going to install MySQL. So basically that is going to be your database server. And then on here too, you are obviously going to have a folder for your files, right? So when a user goes to your website, right, whatever your website is, Apache Web Server is going to present that website basically from the information that it pulls from your MySQL database and the files that it has, that is going to go to the user. The user will interact with that. That will then go back to the Apache Web Server. That will send, information to MySQL, and will send information to your files and that type of thing. So this is where you have everything on the exact same box, and that's probably what you're used to. But as you start scaling out and you start thinking about how you're going to be designing the architecture, you might think about designing it so that these are different servers, right? So basically here, you might have your web server. Again, so this will be a Linux box, and this will be Apache. But what we're going to do is that is going to be its own solitary box. Now, let's say there's going to be a lot of communication to your server. So this isn't just simply going to be your little blog that you're going to have, but let's say it's a big e-commerce website. You're going to compete with Amazon somewhere in the future. So you're going to need a database component. But the thing is, you don't just need a database database, right? You don't need it on the box. You need something a lot more robust. So what you might do is you might create what is called a cluster of database servers, right? So this is something you can do. Basically, all of these servers are communicating with each other, and Apache basically communicates directly just with this cluster. And the idea here is if any one of these machines or two of these machines fails in the cluster, it won't be any big deal. Because the other machines will be able to provide the record resources that your web application needs. Again, if you have files that you need to deal with, you might be looking at it and say, you know what, I'd rather just do something like AWS, right? So AWS has their storage buckets, and so Apache could communicate with the AWS storage bucket. That way you can just keep dumping files into your data store and not have to worry about partition size or that type of thing, right? So that's one of the ways that you could do things like architecture. Beyond that, we'll talk about it in other sessions. You can have what is called service-oriented architecture. So let's say you don't want to be responsible for a lot of the maintenance of the services that your platform is going to provide. Let's say you need to send out email alerts. You need to send out, let's say, SMS alerts, that type of thing. Well, what you could do is you could have your server, right? Maybe this is an Apache web server, something like that. And then when you need to send out emails, so if you need to send an email out, you can use something called an API call to a platform called SendGrid. And so what SendGrid does is it sends out SMTP. You can either send or receive email messages through the SendGrid platform. And that way, basically, you have all of the email functionality without actually having to worry about the server itself. Again, along with the API, there's something called Twilio. And so Twilio does SMS messages. So you can simply add SMS messaging components to your system. Without actually having to worry about an SMS server, dealing with telephone lines and that type of thing, right? So these are the different things to be thinking about when we start talking about architecture. Basically, the idea here is how are you going to be designing the resources that your solution is going to require, again, from the standpoint of what will be best for speed and latency, what will be best from a price when you go at scale, and what the institutional knowledge of your organization is, so they can actually support whatever it is that you're trying to build. So that gives you a basic idea of what systems architecture is. To be clear, systems architecture on the whole is a profession unto itself. There are systems architects out there that companies hire just to figure all of this out, right? So you, as a coder, what you need to be thinking about, again, as I talked about before with being a full stack developer, basically what I would say is you just need to figure out the resources and the architecture design that is best for whatever solution that you are trying to create. You do not have to figure out all the millions of different ways you can connect all these systems together. You need to figure out what is going to work best for the thing that you're trying to deploy. And basically, when you narrow it down, what you're going to find out is all of this stuff is relatively easy. Again, if you're just focused on what it is that you're trying to deploy, you're not trying to deal with the wider world. If you're interested in more with the systems architecture, we are going to have more classes within this particular series of classes talking about some more about systems architecture. But we are going to have lots and lots and lots more entire series of education where we'll be talking about networking, where we'll be talking about servers, where we'll be talking about architecture. And so that is going to be a much larger subject that you can get into if you want to get into it.